This is my data structure lab, exercise number 7, merge sort and quick sort. This is a program for merge sort. In this, let's go on the first main function. The main function. In this, I have taken an array A, and then I have prompted the user to enter the array one by one. And the size of the array here I have taken. Actually, the size of the array is 10. I have taken, and then okay, let's take it 5. So, and this loop runs the 5 times, and the 5 elements are entered in the array, included in the array. So now a function merge sort is called. In this, I have passed parameters. The first parameter is array A, and the second parameter is the lower bound of the array, and the third parameter is the upper bound of the array, which are 0 and 4 respectively here. So this merge sort we are calling the merge sort function here. Let's move on the merge sort function. So this is the function merge sort. In this, I have taken a variable mid, and I have passed low and high. That is the lower bound and upper bound. If low is less than high, mid will be low plus high divided by 2, and then it will call merge sort a comma low comma mid, and again merge sort a comma mid plus 1 comma high. Actually, this merge sort is a divide and conquer algorithm. In this, first we'll divide the array into two, and then those two parts will be itself individually divided into two, and then again they will be divided into two until we get the uh, one element in each array. That is the atomic array. So this is the recursive algorithm. This merge sort will call itself again and again these functions, and then merge one a comma low comma high comma mid. This is going to merge all the arrays that are sorted. So let's see what is merge one. In this merge one, we have passed in the address of the array, and then low, high, and then mid element. So here we have duplicated the copies. I is equal to low, k is equal to low, j is equal to mid plus 1, and okay, see, and then we have taken an array c10. That is the array that is sent here is a is copied in c10. Okay, so while I less than equal to mid and j less than equal to high, this loop will execute till I is less than equal to mid and j is less than equal to high. And if ai is less than aj, the elements which are in AI will be copied to CK. Let's see what is K. K is low, so it will be copied in the C array if AI is less than AJ, and K will be increased so that the next value that is copied will be copied in the next position of the C, then and then I plus plus. So in the else part, CK is equal to AJ, and K will be incremented and J will be incremented. If that is if aj is less than ai, then this else part will be executed. Now there is again a while loop. If I less than equal to mid, then if I less than equal to mid, then means the remaining elements that are in the array after the sorting will be copied from a I to ck, and then k will be incremented and I will be incremented, and then in this while loop, if j is less than equal to high, these elements that are in aj will be copied to ck, and then k will be incremented and j will be incremented. And this for loop will copy all the elements of c into a. That is the original array a, and it will return a. So this merge one will merge all the individual arrays that were divided to sort for sorting, and now it will return to the main function, and it will display the sorted array. This is sorted. So this was our merge sort. Let's see the output. Enter the elements one by one. So let's enter the 5 elements: 1, 8, 5, 3, 7. The sorted array is 1, 3, 5, 7, 8. So this is our sorted array. This program is working, as you can see. And next see our quick sort algorithm. So this in this quick sort, this is also a partition type of algorithm. We have to partition it, but not as we did in word sort. It is different from that. Like see, in main function, first we'll from the user to enter the array, that is 5 elements in the array, and then we'll call the function quick sort. In this only we have passed 0 comma 4, that is means the lower bound and upper bound of the array, 0 and 4 respectively here. And this quick sort will move to this function quick sort, and this if right is greater than left, that is if upper bound is greater than lower bound, p is equal to partition left comma right plus 1, and it will call this partition. This I'll explain you again what is this partition. Then it will call quick sort left comma p minus 1 and quick sort p plus 1 comma right, as we did there, as we took mid the uh, merge sort. So what this partition is going to do, it will find p, that is the pivot element in partition in L comma R, that is the lower bound and upper bound. It passes, and then in this we have created a duplicate copy of L and R, that is I j. I is equal to L, j is equal to R, and pivot we have taken as, first we have taken as A1, sorry, AL, yeah, at the L position, that is the lower bound position, that is A0 here. So there is a do while loop. This do while loop will execute till I is less than j. So first it will do inside this do while loop. There is another do while loop. This I plus plus till ai less than pivot. Initially we have taken pivot as the first element. Till ai is less than pivot means the array we are traversing is less than pivot. It will increase the I, and then again this do while loop, again the second do while loop will increase j till aj is greater than pivot. Now it will check if I less than j. If I less than j, it will swap ai and aj, and now this do while loop will finish. It will do so, and then again it will swap al and aj. Now it will return j, that is the pivot element, and now the pivot position is found of the pivot element in the j position. It will return this j, and the control will come to this p. P is equal to j. So again this recursion algorithm will work, and by partitioning we will sort the array. So let's see our output. uh, Suppose we enter some number randomly like 5 7 2 5 1. Now the elements are sorted 1 2 5 5 7. So this was my program, the merge sort and quick sort. Hope you understood it. Thank you.